So here we have a wedge-shaped metal conductor of length L, varying with uniform thickness connected to a cell like this. Which graph best shows the average drift velocity of electron in the conductor as it varies with distance? Okay, so you imagine this circuit, there is charges moving. Say charges are inside here. So there'll be like charge, charge, charge. And they're all kind of moving in certain direction. I'm assuming they're positively charged, conventional current. So each of these will have a drift velocity. There's an equation for drift velocity that we should know. That will be I equals to nav q or nave or nav q. Here is what? Electrons, right? So nave. V here is the drift velocity. And they ask us drift velocity in terms of position in this funny shape wedge. So let's rearrange this and see. V equals to I over NAE. So throughout this entire thing, what is changing, what is constant? The first one I can say for sure is constant is current. It's a bit counterintuitive, right? But current throughout the entire thing will be the same. Cannot suddenly increase current, decrease current ma. Yeah, in one circuit only got one path. So current is constant. N is number density. Is also constant. Why? Because this is all the same conductor. Yes lah. Metal conductor. Same metal. Throughout the entire X to Y journey, it's still the same metal. Copper, copper, iron, iron, oh. Metal, metal, oh. So this one is constant, not changing. Area though is changing. Because if I draw the wedge in a 3D picture, it will look something like this. My drawing. Yeah, okay lah. This is our cross-section area. So this is a side view of the same wedge lah. If I tilt it a bit and see, okay, that's our thing. So it has uniform thickness, varying with uniform thickness. I suppose they mean thickness is this thickness T. Okay lah, can lah. So it's uniform thickness varying with. Okay, sure. So how do we know what the graph is? Based on the equation on the left side there. Is it straight? Is it curved? Okay, let's think about elimination first. Which ones can we cancel out for sure? So as we look at this equation, we can conclude that E is a constant. So all they have is velocity is proportional to 1 over area. Then you look at this graph. As you move from left to right, is the area, cross-section area increasing or decreasing? So you see the area here at first is small, but it's getting bigger and bigger as you move from X to Y. So area is increasing. So that's how, maybe you can write down first. Area, if area increases as you move from left to right, what would happen to our drift velocity? So let's do a quick check. Area increase means velocity must decrease. Inversely proportional relationship. So then we can already cancel out some graphs. This B is not correct already. V should decrease. D also not correct. V should decrease. So slash it out. Now if you're out of time, you just ding dong dang A, B, D. A, B, C, choose one. So here's one way to eliminate one of the choices. Look carefully at A and C. You start off both of them at a very high drift velocity. Quite fast, I mean the electron all moving inside there, all the charges. Pew, 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 all moving. But then if you go to the other length L, walao, why you stop moving? Stopped moving? Nani? Is that possible? Can charges just stop moving in a conductor? But there is current. No, something's funny here. something is very suspicious. Drift velocity will never go to 0 if there is current in the conductor. It will approach 0, but it will not just go to 0. Just like that. Okay, so this one is most suspicious. Best choice is A. Sus. This one very, very sus. What is going on down there? Alright. So this is the elimination method of solving this question lah. If you are not convinced and you're like, Miss, I must know a method to convince myself if this is correct. Sure. You want to know the method to confirm? You create an equation to tell you what graph this is. So, sure, why not? Let's talk about the equation for this thing. This is only if you have time to do this during, well, actually solving the paper. So how do you convince yourself that it really is A? Where is the equation? Let's start with V proportional to 1 over A. So this is our convincing method to hopefully convince ourselves. V proportional, okay, never mind, let's go back to V equals to I over NAE. We'll just call all of them constants, C, I suppose, over A. These are just constants lah. All the other thing that is constant. What is the area of this tiny little wedge? It's a rectangle. So it's gonna be a width times thickness, T, I suppose you could call it that. Okay lah, width times thickness. So this drift velocity will be some constant divided by width times thickness. Which one is constant here? Thickness, right? Looks correct. Yeah, thickness is same all the way. So width is the one changing. Okay. So thickness, I throw inside the constant again. Okay. I'm just going to ignore it. Let's call this another constant, K. Yet another constant. Because I just want to see what is changing. Width is changing. Yes, width is changing. It's called the width. Okay, how does width change in relation to length? If you look at this graph, it looks strangely like a graph. If I plot width, kind of like width lah, okay, width against length, it's like this, right? Right. Looks like the shape of the thing, right? As you go along in L, it gets thicker and thicker. So this one, I can just call it some initial width. What is this equation? It's a straight line equation. Y equals to mx plus c. But in this specific form, I would call it W equals to M L plus W naught. M is just gradient. I don't know what that is. I just give it a name. I don't know what that is. Just sub that in. V equals to K divided by, what is W? ML plus W naught. There is your equation for this whole setup. How do you use that to determine the graph? You need to know the properties of graphs. What's our vertical axis? V. What's our horizontal axis? X. Oh, not L, X. Sorry. Change this to X axis. Okay, sorry. Move this X. Our horizontal axis is X, so MX is there. Let's put the X here. X, there we go. X-axis is just X. So this is kind of what we call a reciprocal graph that has been transformed. It's similar to y equals to 1 over x, but now you have to multiply by some constant k, and you have to shift your graph a bit because you got a plus some constant again. Okay, so this is what we call, I won't write out the thing, this is reciprocal graph shape, which is a curve. It's not a straight line. It's 1 over something, which looks something like this. Let's see, plus W naught, so like this. Okay, that's how the full graph would look like if you plot it out. But we just look at this part, which is right here. It's okay if you don't know how to do this. You can use the elimination method mentioned earlier. But if you know both and you have happen to have extra time during a test, this is one way to confirm any kind of graph question. Not just this question, any graph question. If you can create an equation to convince yourself it's correct, then it is probably correct. Okay, so that's all for this question. My head's blocking. Quite a tricky one.